So in this syllabus are contained, as far as you are working with exponents, you need the laws of exponents. Each and every part that you're going to talk about, it is all about the laws. In this exercise that we are having, we are asked to use the laws of exponents. And if we are to consider what we are given, it is a conditional whereby we are given exponents which can be expressed as fractions. Okay, like this concept, let's say we have got this way. I talked about this in the introduction, that if we are given x to the exponent of m to the exponent of n, it is the same thing as x to the exponent of mn, which is the product of the two, the product of these two exponents. Okay, with the same situation, if we are given even terms under a product also, that is xy to the exponent of m, everything inside of the bracket is going to be raised to the exponent of m. So it will be x to the exponent of m, y also is going to be raised to the exponent of m. So the question is, how can we evaluate these typical questions? We need these situations. As long we can write our numbers in this format. So I say that, one, as long you are simplifying exponents, the first thing or what you're supposed to consider is that always use prime numbers. Always use prime numbers. If you want to be safe, try by all means to use prime numbers. Why? Prime numbers, these are the simplest numbers that we can ever talk about on earth, because it is just one and itself. 2, 3, 5, 7, 11, 13, 17. These are prime numbers. It is just one and itself. So that's the simplest number that we can ever have on earth. Now, let us consider this. We are given the first question. Simplify number 1, 64 being raised to the exponent of 1 over 6. So the question is, you are not supposed to use your calculator. No, you are not supposed to do that. So this is what you are going to do. All right, I want you to see something on your calculator first before we talk about this question. If you were to consider this condition of our question, this is your calculator here, you are going to have something like this. 64 raised to the exponent of 1 over 6. And this is a 2. That's a 2. So the question is, how are we going to have this? 64 to the exponent of 1 over 6 is a 2. But they do not want you to do it this way, using a calculator. No, they want you to use the laws of exponents. So this is what you're going to do. You have to write this 64 as a prime number. 64 is not a prime number. So it's either we are going to write this 64 as a number which is 2, as a number which is 3, as a number which is 5, as a number which is 7, 11, as long as it is a prime number. So looking into these numbers, we can see there is a relationship between the 64 and the 2. So it is 2 to the exponent of what, which is going to give us a 64. If you do not know this, it is not a mistake. It is not actually something that you can worry about, because your calculator is also there. So you try, at least know that I'm going to use the base of 2. So you try 2 to the exponent of 5, that is a 32, 2 to the x, until you get the number which is a 64. So you see that the 2 to the exponent of a 6 is the one that is going to give us a 64. 2 being the simplest number on earth, which is a prime number. So this is going to be 2 to the exponent of a 6, but everything being also raised to the exponent of a 6. So that is where now this part is going to play a role, which is these laws. An exponent to an exponent, we are going to multiply these together. That is m times n. So meaning to say we are going to multiply this. That is 6 times 1 over 6, which is same as 6 over 1. So this simply cancels. That is going to be 2 to the exponent of a 1. And 2 to the exponent of a 1 is what? Is 2. Any number to the exponent of a 1 is that number as it is. So this is how they are expecting you to be answering these typical questions. As long you are working with the laws of exponents, you are not going to use a calculator. No. The square root of 64, we do know that the square root of 64 is 8, which is plus or minus 8. But in this case, they just want you to work with positive values. So do not worry about the plus or minus concept in N2. They are not going to consider that. But this is the condition. All right, we are given number 2, the square root of a 64 using the laws of exponent, because we are supposed to use exponent laws. The square root is same as to the exponent of a half. So this is 64 to the exponent of 1/2 whenever we have a square root. Writing the 64 as a prime number, which is the simplest form, like I said here, always prime numbers. We saw that 64 can be written as 2 to the exponent of a 6. But there is an exponent of 1/2, which is outside of the bracket. So there we are back, an exponent multiply the 2. So meaning to say we are going to multiply these two numbers, 6 times 1/2. That is going to be a 3. If you use your calculator, that is going to be 2 to the exponent of a 3. And 2 to the exponent of a 3 is 8, meaning to say 2 times 2 times a 2. So the question is, you are not supposed to use a calculator in these simplifications. It's all about the laws. Everything that you're going to do is supposed to be guided by the laws. We know that the cube root of 125 is a 5, but they do not want you to do that. They want you to properly solve until you get that. So number 3, we are given the cube root of 125. The cube root of 125 is same as 125 to the exponent of 1/3. There is a 3 inside of the root, so it's 1 over the number inside of the root, 1 over the number inside of the root. So there we have got a 3 inside of the root, so it's going to be to the exponent of 1/3. So 125 to the exponent, remember, as the simplest number, 125. Talk of the prime numbers, we said we've got 2, 3, 5, 7, and so on. Which number are we going to think about? That is a 5. So you can see, guys, 125 and 5, there's something there common. But it is 5 to the exponent of what? Which is going to give us 125. So you try on your calculator, 5 to the exponent of 1, 5 to the exponent of 2, to the exponent of 3, until you get 125. You are going to see that it is 5 to the exponent of a 3, which gives us 125. So 125 is same as 5 to the exponent of a 3. But there is already an exponent of 1/3, which is outside. So an exponent and exponent multiplies each other. 3 times 1/3, that is going to give us a 1. So this is 5 to the exponent of a 1, which is a 5. So this is what they are expecting you to be answering these typical questions. All you just need is to make sure that the laws are being applied properly on each and every part that you are given. Each and every part that you be given. So these are the typical questions. Consider number 4. If you're given this is the 4th root of, so this is the idea there. If you are given, let us just say, we are given the nth root of a to the exponent of m. This was taken where? That is what you need to know. This was taken from a to the exponent of m over n. So meaning to say, if I am given this condition, it's m over n, the exponent over what is in the denominator. So meaning to say, on this question number 4, where we are given, that is question number 4, that is the 4th root of, so this is the 4th root of 16 to the exponent of a 3. So what does it mean? It means that this can be written as 16 to the exponent of the exponent over what is inside of the root sign, the exponent over what is inside of the root sign, m over n. So this is 3 over what is inside of the root sign, 3/4. So in simplest form, 16 can be written in the base of 2, which is 2 to the exponent of 4 being raised to the exponent of 3/4, which originally we have in this case. So simplifying this, we are going to have 4 times 3 over 4 exponent, that's 2 to the exponent of 3, meaning to say 2 times 2 times a 2, that is going to give us 8. So this is how you use your laws. So we are going to have as many questions as a continuation from this activity that we just answered now, so that you are able to answer any question that you are given in your syllabus. But for now, that's it. Till we meet again.